talk about surface area and volume. So we'll go over some of the formulas for the common shapes, and then we'll do some examples so that, you know, we have some practical work with it. So the common shapes are cube, cuboid, then we can have a sphere, and then I'm gonna go down here. We can have a cone, we can have a cylinder. These are the most common shapes that you will encounter. Trying to think of anything else. We have sphere, cone, cylinder, cube, cuboid. I think that's good. So we have volume and surface area for each of them. So we start with volume, right? So volume is like a measure of how much space is inside that shape. So we all know what a cube looks like, right? It's just like a square with 6 sides, 6 squares all put together. So how much volume is inside that thing? Well, the volume is equal to the length cubed, because you're gonna do length times width times height over here for a cuboid. Length times width times height, and in a cube the width and the height are also equal to the length, so it becomes length times length times length, which is length cubed. Now we have a sphere. So we know what a sphere looks like. If we don't, I'll draw like a sphere. So it's hard to draw it, but it's a 3D circle. That's what a sphere actually is, right? Imagine this was 3D. The volume is given by 4 pi r cubed divided by 3, and r is the radius of the sphere. So is the length from here till the center of the sphere, or the length from here to the top, here to here, here to here, from the middle to anywhere on the sphere, to the edge of the sphere. That's the radius. Now let's do cylinder first before cone. So the volume of a cylinder is equal to pi r squared times height. So if we have a cylinder, so let's say that's our base. No, that's our cylinder. So this is r right here, and this is h right here. So that's pi r squared, so the area of the circle times height. And in general, for any shape, it's a shape in general, the volume is really the area of the cross section. So I'm going to write area cross section times the length of whatever that is. So in this case, in the cylinder, right, the cross section of the cylinder, the cross section means like if you take that section of the shape and then you just repeat it many times, you end up getting the whole shape. So like in this case, if you take this circle right here, right, the area of that is pi r squared, and then you just have an h length of those type of circles, then you get the whole shape, you get the cylinder. So you just multiply by the length, which in this case for the cylinder is just h. And the volume for a cone is very interesting because it's also pi r squared times height, but then divided by 3. So what that really is saying is that if you have a cone, right, let's say that's our cone. So this is our r and this is our height. The height is the perpendicular height. So this height right here. That's saying that if you have 3 of these, then you'll be able to fit it perfectly into this cylinder right here. Exactly 3 of these cones will fit into, and you can do like an experiment. You can take like 3 cones and you can take a cylinder with the same radius and the same height as the cone and fill up 3 cones and see if it fits into that cylinder exactly. It should. You can search up other videos on YouTube. It should fill in exactly that cylinder. Now surface area. Surface area, all it really is just the area of all the faces of the 3D shape we have. So for a cube, right, let's say our cube looks like this. So just forgive my sketches, they aren't the best, but let's say that's our cube, right? Let's say all the sides were equal length. So this is L, this is L, L, everything's L. So the area of one of the faces is just L squared, right? But then we have 6 identical faces, so it just becomes 6L squared. So that would be the surface area of the cube. So the surface area for cuboid is going to be 2 times length times height plus 2 times length times width plus 2 times width times height. Because you have 6 faces in total, you have 2 of them that are the same length and height, 2 of the same length and width, and 2 of the same width and height. Now, the surface area of a sphere is actually equal to 4 pi r squared. And there's 2 ways to think about this, or at least 2 ways. So imagine you had a circle, right? If you had 4 of those circles and you put them together in a specific way, you'd end up getting that sphere. That's what it's actually saying. And also, if you watch the video on differentiation, imagine this was y, right? Imagine we had y is equal to 4 pi x squared 4 pi x cubed over 3. So in this case, v is equal to y and r is equal to x. If you found dy by dx, that is actually equal to 4 pi x squared, which is also equal to the surface area. So the derivative of the volume with respect to radius is the surface area. You don't have to worry about it, it's just additional information. You can see what that means on the internet if you're interested. Now, surface area of a cone, how does that work? Well, that is pi r squared plus pi r, and then I'm going to write L. Now, L is not height. So remember this cone right here, we had height. So the height is this thing right here. So from the base to the top of the cone. But this length right here, this slant height, is called L. So L is different from H. L is always bigger than H because it's like a right angle triangle, right? Because you have a radius and then you have a height. So well, I guess technically L is equal to the square root of height squared plus radius squared. And that's the surface area of the cone. And the surface area of a cylinder is given by 2 pi r squared plus pi r h. So I think it's plus 2 pi r h, actually, yeah. 2 pi r squared plus 2 pi r h. That's the surface area of a cylinder. So that's the area of this and this. That's 2 pi r squared. And then pi r h is how you calculate the area of this curved surface. So let's do some examples and I guess it will make more sense. Okay, so we have this question right here. The diagram shows a solid cone and a solid hemisphere. The cone has radius 2.4 and slant height 6.3. The hemisphere has radius capital R. The total surface area of the cone is equal to the total surface area of the hemisphere. Calculate the value of R. And then here it gives you the formulas that we saw previously. So this is the formula for the curved surface area of a cone with radius R and slant height is pi RL. So that means the area of like this section right here, the top, is pi RL. But then we have to add to that the area of the circle, which is pi R squared. So let's write that down. So the surface area cone, so I'm going to do SA and then C, is equal to pi R squared plus pi RL. And then the surface area of the hemisphere, I'm going to write SAH, that is equal to, well, surface area of a sphere is equal to 4 pi R squared. So of a hemisphere, which is basically half a sphere, it's 2 pi R squared. But now we have another shape. We also have a circle on top right here. So that also has a surface area, and that is equal to pi r squared, because this is the area of a circle. So this is actually equal to 3 pi r squared, and we need to find r right here. Well, we have the numbers for this small r, we have the numbers for this L right here. So if you put that into the calculator, you get 47.5, which is the curved surface area of the cone, that's pi RL, plus pi r squared, which is equal to 18.096. Then you can add that up and you will get a certain, I can put it on my calculator right now and see what that gives us. So we have 47.5 plus 18.096. So 65.6, approximately 65.6. And then here we just leave it as 3 pi r squared. We can't do anything more with this. Well, then we have 3 pi r squared is equal to 65.6, because it tells you that the total surface area of the cone is equal to the total surface area of the hemisphere. Then you can just solve for r squared. So if you divide both sides by 3 pi, you get 65.6 divided by 3 pi, which is 6.96. And then you get r is equal to plus or minus square root of 6.96. But we only care about the positive because the radius can't be negative. So 2.64 centimeters. And that's our value for r. Let's go to the next question. So r is equal to 2.64. Oh yeah, of course, don't forget the units. Are we in centimeters? Yeah, we are. 2.64 centimeters. The diagram shows a solid cone with radius 7.6 and height 16. A cut is made parallel to the base of the cone and the top section is removed. The remaining solid has height 12 as shown in the diagram. Calculate the volume of the remaining solid. Okay, so this solid is actually called a frustum. That's the name for this solid. It has an actual name. It's when you remove a smaller cone from the bigger cone. So how do you calculate the volume of a frustum? We didn't see this in one of the formulas, remember? Because we only found the formula for these shapes. But I'm telling you that by using the formula of just the volume of a cone, we can find the volume of this shape as well. So let's think about it. So this cone that was removed, what does it look like? Well, if you try to reconnect, it looks something like that, right? And if this is 12 and this whole thing is 16, that means this height right here is 4. Do we agree? Because 12 plus 4 would give us 16. So that height is 4. Now what's the radius? The radius is not 7.6 anymore, because 7.6 is this whole thing. What's that small radius? Well, let's say they're proportional, right? Because it's a shape, should be proportional. So if we did the new height divided by the original height is equal to the new radius, let's say r, divided by the original radius, which is 7.6. I think that's a fair assumption to make, and this is in fact true. So now we can find the new radius to be 4 times 7.6 divided by 16, which is 1.9. So we have 1.9. So now we know what the old cone looked like. It had a radius of 1.9 and a height of 4, and that's all we need, because to calculate the area of this frustum, we can take the area of this big cone minus the area of the small cone. We can take the volume of this big cone minus the volume of the small cone to calculate the volume of the frustum. So how would we do that? So the volume of the big cone, so VB, B for big cone, is equal to pi times 7.6 squared times the height is 16 divided by 3. So if you do that on your calculator, you end up getting approximately 967.78. And then the volume of the smaller cone, so I'm going to write that as Vs, is equal to pi times, the new radius is 1.9 now, so we have 1.9 squared times the new height is 4 divided by 3, which is equal to, put it in the calculator, 1.9 squared times 4 times pi divided by 3, which is equal to 15.12. And of course we should have the units everywhere, so this is centimeter cubed, and this is also cubic centimeters. So what's the area of the volume of the frustum? So Vf is what we need, is equal to, well, the volume of the big cone is 967.78 minus the volume of the small cone, which is 15.12. What do we end up getting? We end up getting 967.78 minus 15.12 is 952.66. You can round that off as much as you want, but I'm going to leave it at 2 decimal places, and that's the volume of the frustum, 952.66 cubic centimeters. So yeah, those are examples of volume and surface area. I hope that made sense. These are the formulas again, all that you'll need to know. So yeah, it's a good idea to memorize them, but also a good idea to like learn where they come from. These are a bit more difficult to grasp for like sphere and pi r L and 2 pi r H, but at least try understand where they come from, and if it doesn't make sense to you, then just do many problems and hopefully it will click eventually. So yeah, like, comment, share and subscribe, and let me know what else you want to see in future videos.